Here's an example in which we're trying to find the magnitude of a complex number. It's also called the absolute value. Absolute value or magnitude of a complex number. And so what is it? So it's the length of it, the absolute value of it. It's the square root. If you go back to the formula sheet, if you look on the notes, it's the square root of x squared plus y squared, where this is the x, square root of 3, and this is the y, which is 6. So that's square root of x, which is root 3 squared, plus y, which is 6 squared. And so that's the square root. Now, do you know what happens there? When you do this, the square and the root cancel, and it's just 3. The other one becomes 36. And so, yeah, 36. So that becomes the square root of 39. So there it is, square root of 39 on that one. Do you see what happened there? The length or the magnitude or the absolute value, goes by all three names, of a complex number z is the square root of x squared plus y squared. It's basically the Pythagorean theorem. And so this is the x and this is the y. And when you square the root of 3, the root and the square cancel, and it's just plain 3, but the square of the 6 is 36, that's square root of 39. Now I want to remind you, if you get a number, I want to remind you two things. If you happen to get a number like square root of 40, how to simplify? Do you know how to simplify? You have to break it down. 4 times 10, 2 times 2, 2 times 5. So you'd say the square root of 40 would be 2, 2, 2, 5. Right? 3 2's and a 5. That's the breakdown of the square root of 40. And then you ship stuff out of it. 2 for 1. So 2 2's in, send 1 2 out, and they're gone. So it would be 2. And the 2 and 5, which have to stay in, would go back to making 10. So square root of 40 would simplify to be 2 square root of 10. Do you remember that? About simplifying square roots and how that works? So again, you break down the 40, 3 2's and a 5, and it's a 2 for 1 ship out. You might think that's weird, but if you think about it, that's what we always do with square roots. Think about square root of 25. What is it? It's 5, right? What just happened there? What was in that 25? 2 5's, right? Isn't that 25 the same as 2 5's? See what happened? 2 5's in, 1 5 out. That's what square roots always do. So 2 2's in, 1 2 out, and they're both gone. That's what we always do with square roots. So that would simplify to be 2 root 10. Also, I want to show you where the formula comes from. One last thing. I don't like giving math rules without reasons. Oops. Think about what we just did there. So let's graph it on the complex plane. Remember the complex plane where this is the real and this is the imaginary axis. The x-axis is the real. The y-axis is the imaginary axis. And we're going to put the number square root of 3, 6. So that would be like over square root of 3 up 6 to that point. Well, here, let's just do it this way. We found the point. It's going to be over square root of 3 up 6. That would be the complex number right here. Square root of 3 plus 6i would be located right there in the complex plane. Now, if you want to think about what the distance is out to that point, it's right there. This is going to be the length out to the complex number. And how are you going to get that? It's Pythagorean theorem, isn't it? Right? You would just take this squared plus that squared equals that squared. You'd say the length squared equals the root 3 squared plus the 6 squared. And then, well, here, let's just wrap it up with this. And then you would just root it to get the length. And that's exactly what we did. That's where that formula comes from. It's just the length out to a complex spot on the complex axis, which is x squared plus y squared, the square root of it. So there we go. That's all bonus information. We were done back here with the square root of 39.